Sorry, I don't think you heard my spiel. Sorry. I realized my microphone was off. But again, here, my name is Joey. I'm going to be your math teacher for today. What we're doing today is, if you're tuning in for the first time, we are going through the series of answering questions in terms of math and chemistry. So if you're tuning in for the first time, again, thank you for watching. And what we're doing is through this series, we're answering some of your questions in terms of in secondary school subjects such as math and chemistry. Again, my name is Joey. I'm coming in to this with experience in chemistry and math as well, and I teach this subject in a secondary school level. So again, if you're tuning in for the first time, thank you for watching. I'm so sorry that my mic, I forgot to turn on my mic, so you didn't hear my spiel. It was just me talking, it's me moving my mouth. So super sorry about that. But I think the problem is now fixed. So what we're going to do is we're going to get started on our 10 questions for the day, and this would be particularly questions asked in probably from grade 9 science all the way to grade 11 chemistry, and then we're going to reconvene at 2 p.m. and then do questions probably asked in grade 12 chemistry. So what we have here is, so our first question for today, it says, how many valence electrons does nitrogen have? So this is our first question here. How many valence electrons does nitrogen have? So let me write this question down for you here on my board. And what I have here is I also have a periodic table open as well. So we can use this and refer to this as we kind of do our questions. So let's do, so it says how many valence electrons does nitrogen have? So take a moment to think about this question. Particularly in this topic of what is a valence electron. So when we talk about what is a valence, so in order for us to answer this question, we have to think about what is a valence electron and how does that differ from an electron. And then we also have to think about our where does nitrogen lie on the periodic table, and after a minute or so I'll tell you where it kind of lies on the periodic table. Actually, maybe I can put this here so I can kind of show you here in terms of the periodic table. So it says here, how many valence electrons does nitrogen have? So again, take a moment to think about this question, and then we'll reconvene in about a minute, and you can think about this question. If you're in the chat, again, we can wave hi and you can answer the question if you want to help me out, or you can kind of just listen in and see. And if you're unfamiliar with this concept, or if you're familiar, you can feel free to type your answer out in the chat if you're there. So it says, how many valence electrons does nitrogen have? So when we talk about valence electrons, we're talking about this topic of electrons that exist on the outside shell, right? So if you think back from grade 9, think back about Bohr-Rutherford diagrams. Grade 9 general science, or in this case it would be freshman year of science for the US. You have valence electrons, which are basically electrons that they exist on the outer shell, right? On the outer shell, or in the outer shell. Sorry, in the outer shell. Outer shell in terms of because we're only working with Bohr-Rutherford diagrams, I'm using the word shell and not energy level. So that's kind of what the terminology is for from grade 9 to grade 11. So what I could do is I can draw a Bohr-Rutherford diagram. Right, we're pretty familiar with this with grade 9. We have a nitrogen here. We have nitrogen here. It has I can find using my periodic table where nitrogen lies. It's a nonmetal, so it's on the right hand side. So this here is N. This here, it has seven protons, right? So say 7p. I'll just write N here. So if it has 7 protons, it means I have 7 electrons as well, right? So I have nitrogen here, which means I have to fit 7 electrons in our Bohr-Rutherford, right? So this is a bad circle, actually. Sorry. I feel like there's a tool that makes a circle. Oh, there is. Oh my gosh, that's so cool. Oh, this is so much nicer. That's 1. Oh, look at this technology. That's 2. I'm going to need 3 as well. Oh, look, this is so much nicer. Oh, I'm so happy with these circles. Okay, so there's 7 electrons, right? So let me remove the circle tool here. There's 7 electrons. 7 electrons here. So we have 2 electrons in the first shell. So we have 1 and 2 here, and then we're gonna have so if I have 2 electrons in the first shell, I'm gonna have to have 5 electrons in my second shell, right? So I'm gonna write 1 here. Oh, let me do this in red because these will become our valence electrons here. 1, 2, 3, 4, and 5, right? So again, I have here 7 electrons in total. I have 2 in the first shell and 5 in the second shell as denoted in the red, right? So our valence electrons in this case would be our outer shell, right? So which means therefore my answer here is I have 5 valence electrons in nitrogen, right? And we can verify this answer by simply just looking at a periodic table. So what we can do is we can look at a periodic table here. We find that nitrogen here is here, right? And we know the rule in terms of our group rule, right? So if I mean group 1, I have 1 valence electron. Group 2 has 2. Group 13 has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7, and 18 has 8, right? Or in terms of neon itself has 8 in the outer shell, right? So in terms of nitrogen here, we have it lies on group 15, so therefore it has 5 valence electrons. You can look at the last digit. That's kind of a little cheat with the periodic table. So with that, our answer here is 5 valence electrons. So this here is 5 valence electrons. So this here is our answer for this problem. So let me throw this back here. So this here, let's see it from McGill University. The student says valence electrons are electrons present in the outermost orbit of the atom, which are involved in the chemical properties. That's good. You can find the number of electrons by analyzing periodic table. That's good, so they include that as well. Nitrogen is in the group 5A, which is great, so valence electron is 5. That's good. You can also use the electron configuration. You can use that as well, but we don't really know the electron configuration. We don't do that till grade 12 chemistry, so I'm only going to use kind of grade 11 chemistry in this case. So don't worry about electron configuration, but they did get the question right, and they said 5 electrons in the outermost orbital of nitrogen here. So this solution here is correct. It's correct. And great logic. So that's question number 1. Okay, so let's look at question 2 here. Question 2 here states that what is the molar mass of calcium? So what is the molar mass of calcium? Okay, so this is what is a molar mass of calcium. So again, take a moment to think about this question, and then particularly think about this topic of what is a molar mass. And again, we might need our periodic table. So I'm gonna shift this back here, and you can find. Let me know if you find calcium here. So it says here, what is the molar mass? So we have to define what is a molar mass, and where calcium is on the periodic table. So take a moment to think about this. Again, if you're in the chat, feel free to answer this question as well as we look at this problem here. So it says, what is the molar mass of calcium? What is the molar mass of calcium? So when we talk about this topic of molar mass, what we're talking about is the atomic it's specific to a specific element, right? So for example, how we figure out molar mass is we simply just look at the periodic table and we look at the atomic mass of the element. So in terms of calcium, where is calcium in our periodic table? Is it a metal or a non-metal? So in this case, and in all cases actually, calcium is a metal, right? And the metals are on the left side of a periodic table. So calcium, as you can see, is in this is in row 4 or period 4 and in group number 2, right? So if we have that, then what we can do is we have here calcium, and we can look at the atomic mass of calcium. So let's look at here. This is calcium here. It says the atomic number is 20. That's not our molar mass. Our molar mass is our atomic mass of our of calcium, right? It's basically saying how many grams per mole there is in for molar mass, right? So this is measured in grams per mole. So in 1 mole of calcium, how many grams would it weigh? And in this case, it would be 40.07, right? So this here, so the molar mass of calcium, so basically big M, and I denote using big M of calcium equals, so this here states the molar mass of calcium equals, it would equal basically 40.078, right? 40.078, and this is in grams per mole. So basically, it's say in 1 mole of calcium, I have 40.078 grams per 1 mole. So that's kind of my answer here. So molar mass of calcium is this answer. I feel like there's a tool with a square as well. There is. Nice. So this here is our answer, 40.078 grams for moles of calcium. And we can go back and we can look at our solution here. So it says here, molar mass of any given chemical element is given in grams per mole. That's great. That's what we said before. There are following steps to calculate the molar mass of any compound here. And basically what they're saying is they're finding the number of atoms and the relative, and then they're referring back to the periodic table. And basically you're summing all of those molar masses together. So that's great, except in this case it's just calcium, right? It's not calcium hydroxide or calcium chloride or something like that. So we only have one atom of, or we only have one mole of calcium here. So it says here, which means what's the molar mass here? I could just simply look at the periodic table. It's 40.078, so they rounded it up to 40 grams per mole. So this here is a correct answer. So great solution and step by step. And I guess definitions and in defining the molar mass is. Sweet, solution's correct, and we are good to go. Okay. Let's look at our next question. So here it says, classify each salt as acidic, basic, or neutral. Oh, shoot, I'm still on the square tool here, sorry. So it says here, classify each salt as acidic, basic, or neutral. So basically, it's either acidic, basic, or neutral. And we're talking about the following salts. We're talking about, this is K2SO4, which is potassium sulfate. You have NH4NO3. This is ammonium nitrate. And we have here NaNO2, which is sodium nitride. Sorry. So this is sodium. This is sodium nitrite. Sorry, NO2 is nitrite. My bad. So let's look at this problem here. So it says classify each salt as basic. These are all salts. And when we define what a salt is, it's basically we have a cation and an anion in the compound, right? So all of these folk here are all salts, and we define salt as salts, and it's basically a anion plus a cation together. So but basically what we can do is we can actually redraw all of these compounds and we can break them up into its charges, right? So if that helps you visualize the question. So we have here, this is K plus, we have potassium, and we have this is sulfate, or sulfate ion here, SO4 2 minus here. We have here, this is NH4 positive, this is ammonium, and we have the nitrate ion here, NO3 minus, and then we have here this Na plus the nitrite ion, which is NO2 minus. So take a moment to think about this problem. I broke them down to their cations and their anions. So let me erase this. It kind of looks bad here, but I basically drew all of these salts when they dissociate in terms of solution. So this here is in solution here. So so are they acidic, basic, or neutral? So again, take a moment to think about this problem here. It kind of already helped you out by dissociating these compounds for you. But think about the definition of what an acid is, what a basic is, and what a neutral solution here is. You can think of it in terms of like a pH level. Like, is the pH from 1 to 14, is the pH closer to 7? Is it a neutral solution, or is it greater than 7? So it's a basic solution, or is it less than 7, which would make it an acidic solution? So let's look at the first one here. we have here, this is potassium sulfate, and it says here potassium sulfate, we have K plus and SO4 minus, right? So here's an ionic compound. We have metal here, and in this case it's a polyatomic, but it's still a covalent compound. Or sorry, it's a covalent compound here, but it combines to form an ionic compound because this is bond covalently, right? So basically, what we have to do is what we have to define here is first, what is an acidic solution? What is a basic solution? What is a neutral solution? Right? So let me do some red. And remember, acidic solutions basically in water, what they do is they are going to lose their hydrogen ion, right? You can think of it as HCl. For hydrochloric acid, for example, it's going to lose an electron or lose a hydrogen in this case, and then it's going to dissociate into solution, right? So this here is loss of hydrogen, and basic solutions gain a hydrogen, right? So if you think about it as you can think of it as like NaOH, for example, is a good base, right? It gains a hydrogen here. So again, so this is loss of hydrogen here, and then you are going to gain a hydrogen for our basic solutions. And for neutral, it doesn't really do anything, right? It's just a pH 7. It does not lose any hydrogens, does not gain any hydrogens. So when we look at acid and base solutions, we can actually look at it as a neutralization reaction as well. So in order for us to make K2SO4, what we have to do, we need acid base. We have to think of it as a neutralization reaction, right? So we think back to grade 11 chemistry. We talked about this topic of neutralization, or you can think of it as an acid base reaction, right? So we have basically any acid plus any base yields a salt plus water, right? In this case, all of these guys are salts. So basically what we have is we have here S salt is our K2SO4, and water is obviously H2O, right? So we already have these two things already written down for us. But what we have to find out is what is our acid and what is our base, right? So what we can think about is we can actually look at the cations and anions here to think about what our base could be, right? So you have potassium here, a strong metal, and it's not going to, if it combines with a halogen, it's going to make another salt, right? So I would need it to combine with a hydroxide to make it base. Remember, hydroxides are very, very good bases, right? So I can say here this would be KOH, would be a good base, And for the sake of time, I won't balance these chemical equations for you, but you could balance that at home for you if you wanted to. And for acids, we would have basically something SO4, right? So for example, what would be a good acid that goes with this SO4 here? Obviously, I need a hydrogen because I have to lose that hydrogen, right? So, for example, H2SO4 is a great acid, sorry. Sulfuric acid, right, is H2SO4. So you have these two compounds. You have H2SO4 plus KOH. You have a strong base and a strong acid, which means my products are going to be a salt. In this case, it will be a neutral salt, right? This here is neutral and water, right? Because I have a strong base. This is a strong acid, and this here is a strong base, right? And it's going to obviously neutralize to a pH of 7. So that's awesome. So it's a neutral solution. So let's look at B here. So B here, so this here is a neutral. So right here is, this salt is neutral. So we can do the exact same thing with B, right? With B here, we have, I'm going to do some blue here. Actually, this here was, actually maybe we'll just draw a line. And then this is our new solution here. So we have something, it's acid base again. We have, in this case, our salt here is NaNH4, NO3. NO3 plus H2O, right? And again, we have we need a acid and a base to make this salt, right? So let's look at our cation first. I remember a cation in this case was potassium, and we bonded it with a hydroxide, right? So that would create our base, right? So let's put here NH4 NH4OH. So we have here, this is ammonium hydroxide is our compound. And we have NO3. Again, I need an acid, which means I need some type of acid, right? So I have here, this would be H. NO3 would be a HNO3 here would be a great acid, right? This is nitric acid. So again, strong acid. We have NH4OH would be our base here, and then I would get a salt, and then I would get water. So again, in this case, what I can do is if you look at our NH4 here acts as our cation, but if you look at what the pH of NH4OH is, you have to think about, is this a strong base or a strong acid here? So in this case, this NH4OH is actually a weak base, and we talked. This is more so actually a grade 12 question rather than a grade 11 question, because we didn't really get into this topic of a weak base in grade 11. So my apologies here, but this here is a weak base. And the reason why it's a weak base is because it actually forms an acid and base equilibrium when it forms with water. And I can write down that for you here. So if a strong acid, a weak base, my salt here is it's an acidic salt, right? So I have here it's an acidic salt, because the pH of the strong acid is going to dominate the pH of the weak base. And just an aside here, if I were to write the dissociation or the acid base equilibrium, I have NH4OH plus it's going to it's in a solution of water, and basically what it does is I have here, it's going to dissociate into, this here is NH4, let's see, it's going to be a base, right? So it's going to accept an OH. It's going to accept an OH here. So this will become OH2. OH2. Give me a second. This would be OH minus here. So this here is going to dissociate NH4 plus and OH minus. And this here is going to dissociate into water. These two, what they can do is OH minus here can bond with water to create again, you get another acid base equilibrium, right? You have here, this could be H2O, and you would get basically two OH ions right here. So basically, what I'm saying is it basically goes back and forth in terms of acid base equilibrium, because it doesn't fully dissociate in solution here. So let me erase this. It's just a little aside, because this breaks down to these two components, and basically when it dissociates to solution, this here has a pK. This here has a Kb of some value. I don't know what the Kb is, but you can search it up yourself. I don't know what language that is, but I'm hoping you're having a great time on stream, Eduard. Thanks for watching. So that's strong acid, strong base. I get an acidic salt, and I get water here. So this here is an acidic solution in terms of this NaNH4. So right here, this is acidic. And then finally, I have my last question here. The last salt I would have to determine. And this here, the salt here is NaNO2, right? So sodium nitrite. So this here is sodium nitrite plus H2O. And then I have here, this would be, I would get NaOH, for example, is a strong base. So get Na is, again, the metal here, and it's going to bond with the hydroxide. So it's a strong base. And then I get something NO2 here. NO2, I would get HNO2. I need an acid, right? This here is an HNO2. Here is a strong acid. I have nitric acid. This is nitric acid, right? So, or this is HNO2 is a weaker acid, because I have here a strong acid here. Once it loses its first I have nitric acid, which is a strong acid, but HNO2 here is a weak acid. And let me just check for you what the pKa is of this one. So nitric acid is strong, obviously, but HNO2, let me just check the Ka for you. Yeah, the Ka here is 4.5. Nitrous acid is 4.5 times 10 to the negative 4. So this here would be a weak acid. Again, I don't know the pKa value, the Ka Kb values, but I know that this is a weak acid here. So if this is a weak acid, this is a strong base. Again, this here dissociates fully, which means I have a basic salt, because this pH is the pH of the NaOH is going to dominate this weak acid here. And again, I could write the in terms of the weak acid here, this HNO2 plus H2O is going to be in equilibrium with, it's going to get NO2 minus here, and I'm going to get H3O plus here. And this here, it makes it acidic, right? So that's what we're doing in this case here. So so this is here is a weak acid, doesn't dissociate fully. This is the acid. There's some type of Ka here, and I believe the Ka was 4.5 times 10 to the negative 4 here. So yeah, this is actually more so a grade 12 question where we're talking about acid base equilibrium. I thought it was more so a grade 11 question, but again, for general chemistry, this would have been a fair game question here. So finally, I can write here, this is K2SO4 is neutral, acidic would be ammonium nitrate, and this here would be basic here. So let's see. K2SO4 is neutral, is a salt. That's good. Potassium sulfate and potassium. No, this here, forms potassium sulfate. So sulfuric acid, potassium hydroxide forms my salt. Ammonium nitrate, is acidic because I get a weak base. When NH4OH, ammonium hydroxide, is a weak base, and nitric acid is a strong acid, so therefore it forms a weak acid. That's good. So it's acidic salt. And then basic because NO2 is not, this is NO2 is not the list of acidic ions. It is basic. The explanation here isn't the greatest, but what I would have written so I would say good solution, but clear explanation for NaNO2 being basic would be, would be how nitrous acid, HNO2, is a weak acid with NaOH, strong base, would produce a basic salt. So I'm going to basically improve on the solution by writing this here. So HNO2, I know nitrous acid is a weak acid, and this here is a strong base. So the solution is correct either way, but this here is great. So this was number 3. So number 3 took me a bit longer because it was a bit of a harder question, but totally fine. We'll have to move along here. So it's here, which statements, number 4, which statements about subatomic particles are true? So which of the following here is, we're looking for a true statement. So A says that if a atom has equal number of protons and electrons, its charge is neutral. So if protons equals electrons, let's say number of protons, n protons equals n electrons, then charge is neutral. So that's our first statement. B here, electrons are attracted to protons. Electrons are attracted to protons. C states that electrons are much lighter than neutrons. Electrons are much lighter than neutrons. And D states that protons have twice the mass. Protons have twice the mass of neutrons. Okay, so I have 4 statements here. So let's check all 4 statements. So we're looking for which statement about subatomic particles are true. So it says if an atom has an equal number of protons and electrons, it will be charge neutral. This here is true, right? For example, I have my, let's look at pick honestly any element in the periodic. Let's pick lithium, for example. Lithium has in lithium I have here is 3 protons, because my atomic number is 3, right? My atomic number here is 3, and I also have, if I round this to the nearest whole number, this is atomic number of 7. Sorry, atomic mass of 7, which means I have a neutron. My number of neutrons here is 4, right? But I don't really care about the neutrons. 4 neutrons, and then 3 electrons, right? So which means my number of electrons equals number of neutrons, and my lithium here, the charge is neutral, right? So this here, A is correct. Anytime we have number of electrons equals number of neutrons, the charge is neutral. So this is correct. B states that electrons are attracted to protons. This here is also it's a true statement, and in the sense that this is also a true statement is because I'm going to use this topic of effective nuclear charge. When we're talking about atomic radius in grade 11, we talked about this topic of how if there's electrons, when we're increasing atomic radius, when we're talking about going from across a period in the periodic table, so across a period here, we said that atomic radius decreases, right? Because as I expand or as I increase the number of valence electrons, my protons are attracted to electrons, right? And it's going to pull them in closer, therefore decreasing atomic radius. So by that logic, well, we can say that B is also true, right? Because I'm saying here, and I'm using this logic of atomic radius decreases as I go from period left to right, right? From left to right. Sorry, this is really bad, right? From left to right on a period, right? So again, this here, atomic radius decreases, right? Because again, the attraction between protons and electrons basically they're intensified, and what the protons do is they drag they're more attracted to the electrons, so they drag them into the center, therefore decreasing the atomic radius. So B is also true. C here's electrons are much lighter than neutrons. This here is also true. And when we're talking about electrons being lighter than neutrons, we can actually look at the mass, right? And basically the mass of the atomic mass, when we're talking about atomic mass, we have hydrogen here, which has atomic mass of 1, and our proton has an AMU of 1 as well, right? So this here is 1.008, and electrons contribute very, very little to the atomic mass, right? In fact, the mass of an electron, I believe it's like something like 10 to the power of like negative 34 or something. And I can show you what a mass of an electron is. Here it's like 10 to the 31. So 9.11 times 10 to the negative 31. This here is the mass of an electron. And this here is much, much smaller than a mass of a proton, right? A mass of a proton is much, much, much bigger, 10 to the 27, right? So again, this here, electrons are much lighter than neutrons. This here is correct. And again, neutrons and protons have about the same weight here, and which means D here is false, right? So protons have twice the mass of electrons. This here is false because neutrons basically have the same mass as protons in that. So in this case, 4 of the statements are true, right? So this here, I'm not going to summarize this. So it says here, what is it? Answer A here, atomic mass, it is true for subatomic particles. That's good. B here, electrons is true for subatomic particles. Okay, C says it's true. D here is false. And then they explain it. And they said protons and electrons have opposite charge with equal magnitude. That's good. B says the opposite charges attract each other. That's good. C here says mass of electron and mass of neutron. So the mass of neutron is much higher than the mass of electron. Good. And D says the mass of a proton is twice as heavy, or twice the mass of a neutron. Proton and neutron is similar masses. Okay, this here is a great solution. I'm gonna say but poor formatting, because they could have formatted their answer much better. But poor formatting. In creating an answer, because it was just like a block of text, right? Like I don't want to read this. Like it's a block of text. So I wish they had made like paragraphs or something, so this makes it easier for me to read here. So a solution here is correct. Sweet. Okay, this here is number 4. Let's work on number 5. So we are halfway. Number 5 here. So what is acid base? Classify whether KClO3 is acid or base. KClO3 is acid or base. So when we're talking about acid or bases, like we said before, acids again donate an electron, right? They donate an electron. So for example, let me do it in blue, An acid would be something like HCl, right? HCl donates electron, right? So if I put it in solution, H2O, what it's going to do is going to donate. This hydrogen is going to leave HCl, and I'm going to get H3O plus Cl minus, right? And H3O plus here is the hydronium ion. That determines the acidity of our solution here. So pH means, which means it is a hydrogen donor. And our pH is less than 7, right? Sorry, pH is less than 7 here. That's an acid. What about a base? A base is the exact opposite. If I have a base here, I'm going to have, for example, base, I use NaOH as my example, plus H2O. It's going to dissociate and form, so it's OH minus, and then I'm going to have here OH minus plus. I have also and the Na and the Na plus here. So this here I have I have kind of two. Wait, and I can balance. Let me balance this for you as well. OH, I have O and O. I have two O's on this side, and I have three H's. I think I've added an H2O here. Sorry, this here is also H2O. Yeah. So that's solution. But this hydroxide ion here, again, has the determines the pH, right? And again, the hydroxide ion has a pH that's greater than 7, right? So I can say that this is a hydrogen acceptor, right? Hydrogen acceptor. I can say the pH is greater than 7. And then obviously neutral solution would be pH at equals 7, right? So let's look at KClO3. So knowing these definitions, let's look at KClO3. So KCl3 is made up of two things, right? Like if I dissociate this or into solution, I get the cation and an anion, right? I get K plus here, plus I get ClO3 minus here. And ClO3 is chlorate, right? So I have K plus and chlorate, right? And again, what I can do is I can do the exact same thing as my previous question when I talked about acid-base neutralization, right? So let's look at that. So remember, acid-base neutralization, I need here, let me do this in blue. I need acid and base, right? Acid plus base would give me a salt and water, right? In this case, I already have my salt here, right? I have KClO3. The reason why I don't have my salt is I have a cation and an anion, right? So I know that here is my salt plus water, which is H2O. And again, so what would my base be in this case? My base is made up of my metal and a hydroxide, right? So again, here there would be KOH would be my base. So this here is a strong base. And then obviously I have a ClO3 minus here. So I need an acid, right? Which means I need, this would be HClO3, right? So I have here, this is chloric acid plus KOH, potassium hydroxide would give me KClO3 plus water, right? So in this case, I have chloric acid. Let me just find the Ka for you. Chloric acid has a Ka of. Chloric acid is a strong acid. Chloric acid has a Ka of 1, right? So in this case, it dissociates fully in solution, which means I have a strong acid and a strong base. So this here is a strong acid. Sorry, strong acid. This is a strong base because I have a hydroxide. That's a dead giveaway for being a strong base, which means this here is my neutral solution. So in this case, it's not actually, potassium chlorate is actually a neutral solution. It's not acidic or basic. So let's look at, so therefore, write this down. KClO3 is neutral. This here is my correct answer. Sorry. So I have here, it says acid is defined as substances that release hydrogen ions in water. Sweet, okay, that's fine. Acids dissolve in water to form solutions that conduct electricity and have a pH smaller than 7. Good. A base is any metal oxide or hydroxide. It has a pH of more than 7. Potassium chlorate is an ionic compound that is dissociated into these two. That's good. Neither of these ions is hydrolyzed in water, so the pH would be 7. So potassium chlorate is neither an acid or a base. It is a salt formed in the reaction HClO3 and the base KOH. That's what exactly I wrote here, which means solution here, solution is correct, but I wish they included that KClO3 is a neutral salt rather than just saying it is an ionic salt. They say ionic salt? Yeah, ionic salt. So it's a neutral salt. Sometimes you can have acidic salts and basic salts like we looked at in the previous question, right? But I'm going to say solution is correct, but I wish they included this part here. Solution here is correct. Or say the solution. Sure. Solution here is correct. Sweet. Okay, so that was number 5. Let's look at number 6. So sulfur, a metal, metalloid, or non-metal. So sulfur is a, so is sulfur, is this a metal, non-metal, or is it a metalloid? Okay, what's its family name? Okay, so when we talk about sulfur, when we talk about metals, non-metals, and metalloids, we have to look at the periodic table, right? So first, what is the element symbol for sulfur? So our element symbol for sulfur here is S, right? A element symbol is S. So let's look at the periodic table, and let's try to find where sulfur is. Sulfur, I don't see an S in the left side, but I see sulfur here on the right side, and belongs here at number 16, right? And this website is actually really, really good because it just says, oh, I can see it, that's highlighted green, so I can say, I can immediately think it's a non-metal. However, if you're not given this information on a test, what you have to do is you have to figure out where my metalloids are. And the metalloids are kind of the staircase here. So this here, boron, silicon, arsenic, and then antimony, tellurium, and astatine here. It makes a kind of a downward staircase, right? It goes like, what? There's a step here, kind of two steps here, and then another step here, right? So again, I have this kind of staircase here that makes up my metalloids. In this case, sulfur is not included in this staircase, right? So in this case, I can conclude that sulfur here is a non-metal. And what in terms of the family name, what I can say that the family name or the group name is whatever group 16. So I can say here its family name here, you can say it's group 16, and specifically it's a chalcogen, right? So I can say it belongs to group 16. Group 16. And if you don't know it's group 16, again, it's this is group 1, 2, and you can count all the way here. This here is 16. The vertical columns are, this is the first vertical column, second, third, fourth, all the way up to, so this here is the 16th. So I'm going to say this here is our answer. It's a non-metal, and it's group 16. So it says from Johns Hopkins University, sulfur is a non-metal because it's not placed in the metal group. Easiest ways to check is because it's through the periodic table because it saves time. Sulfur is described as a non-metal. Poor conveyor of warmth, okay. Sulfur is dull and brittle, okay, good. Non-metals. Sulfur has a low density because it has less volume for its electron cloud. So this answer is good because it's using in terms of physical and chemical properties to determine if it's a metal or a non-metal. Remember, if it's a metal, you have kind of physical properties such as ductility, malleability, luster. You have all these metal properties specific to metals, and sulfur doesn't have those properties. Sulfur metals are solid in room temperature. Sulfur is a gas in room temperature, right? So again, all these physical properties determines that this here is non-metal. So this here is a great solution. Can also include that sulfur lies on the right hand side of the periodic table, hinting that it could be basically inferring that it is indeed a non-metal. Sulfur is also, did they say gas in room temperature? No. Sulfur is also a gas in room temperature, meaning that it cannot be a metal. So the solution here is correct. Okay, so let's look at number 7 here. Number 7. And it says, what is the molar mass of calcium hydroxide? So 7 here says that what is the molar mass of calcium hydroxide? And again, when we talk about this concept of molar mass, as we talked about before, we're going to have to use our periodic tables, right? I'm going to drag this here, and we're going to have to use our periodic table. So what is the molar mass of calcium hydroxide? So to approach this problem, first we have to write the chemical formula. So what is the chemical formula first? So chemical formula is something, and then what we're going to have to do is we're going to have to add up all the, we're going to have to sum of molar masses to find the total molar mass of the we're going to sum our atoms. We have to count our atoms. Actually, no, let me say count atoms, and then we have to calculate molar mass. So these are our steps here. So what is the chemical formula of calcium hydroxide? So let's see. Let's look at calcium first. So calcium, it's a metal, and it lies on the left-hand side. So this here, Ca here is our metal. So I'm going to say here, this is Ca. So Ca here. Hydroxide is actually not on the periodic table. Hydroxide, you can think of it as a polyatomic atom, right? Sorry, I forgot to put the charge here. Calcium has a charge of 2+. And hydroxide has a special kind of polyatomic ion, and it's denoted as OH here, and it's OH minus. So what you can do is to find the chemical formula, you could do the crisscross method, or you could simply just count the number of atoms for you to eliminate the charge. So again, if I have a 2+ charge here and I have a 1- charge here, I'm going to need 2 hydroxides to balance out this 2+, right? Because 2 plus minus 2 is equal to 0, right? So I need 2 hydroxides to balance out this charge of 2+, which means I have a Ca, here, and then I'm going to have OH 2, right? Because I need 2 hydroxides to balance out this 2+ charge. Because 2 times -1 is obviously -2. 2 minus 2 equals 0. So this here balances out the charges. So this here is chemical formula is CaCaOH2. This is calcium hydroxide. So then I have to count the atoms, right? So again, in this case, I have how many calciums I have in CaOH2. I have 1 calcium. I have how many oxygens do I have? I have this, because it's in the brackets, it's going to be, you can think of it as a distributive property. This here, oxygen, I have 2 oxygens here. And then of course, I have 2 hydrogens here as well. So again, I have all of the atoms here, and now I can calculate the molar mass, right? So if I have 1 calcium, I have 2 oxygens, and I have 2 hydrogens, that will equal, so 1 calcium, so I look at my periodic table, 1 calcium is 40.078, right? So it's going to be 1 times 40.078, this is in grams per mole. 2 oxygens, right? So I have 2 times, and I look at oxygen here. Oxygen here is a non-metal. Oxygen is 15.99. I'm just going to say it's 16 grams per mole. And then I have 2 hydrogens. So I have 2 times hydrogen here. Hydrogen, I have 1.00. I'm just going to say 1.008 grams per mole. And I'm going to add all those up, and I've defined my answer here, right? So let me just, actually, hold up. Let me say that this here is 40.078, because 1 times 40 is 40.078. 2 times 16 is 32. 2 times 1.08 is 2.016 grams per mole. This is also grams per mole. It's grams per mole. And what I can do is add all of these up to get, I'm going to take out my calculator here to solve for this problem. On 40.078 plus 32 plus 2.016, I get a molar mass in total. The molar mass of calcium hydroxide here is 74.094 grams per mole. So this here is my molar mass of my compound, of my calcium hydroxide. 0.94. Sorry, I drew it really bad. Grams per mole. And this here is my final answer. for calcium hydroxide. And this here is, so this is for CaOH2. This is the molar mass of this compound. So this is really big M of this, right? So this here equals this number here, 74.094. So let's look back at our answer here, 74.094, 70.092, about the same thing here because again, B is probably due to rounding or something like that. So again, this is here is close enough, so we're good. Calcium hydroxide is CaOH2, so that's what they got. We got our chemical formula first. We counted the atoms, so they have one calcium atom, so they have this, 2 oxygens, which is this, and 2 hydrogens, which is this. They add it all together and they get 74.094. This here is perfect solution and step by step. Perfect solution and analysis. Solution here is correct. Sweet. Okay, so this here was number 7. So let's look at number 8. So number 8 says, what is the molar mass of magnesium? Molar of magnesium. And again, every time we talk about molar mass, we need our periodic table, right? So when we're talking about molar mass, okay, molar mass is denoted by, this is grams per mole, right? How many grams, how much does it weigh per 1 mole of that element? So in terms of magnesium, is magnesium a metal, a non-metal, or a metalloid? Magnesium is indeed a metal. And they're a good way to kind of cheat and kind of figure that out. Most metals end in IUM, except for aluminum is kind of a metal as well. But for example, germanium is a metalloid, right? So again, it's not, and tellurium is also a metalloid. So it's not perfect, but it's in general, IUMs are metals with elements with the ending IUMs are probably metals. Like look at this entire block here is most of them are IUMs, and the entire block here is IUM as well. These are all metals. So metals, I can find that magnesium here lies here. So this is here is Mg, and as you can see, the molar mass of or the atomic mass of Mg here is 24.305. So which means therefore my molar mass, the big M of Mg is 24.035 grams per mole. And this here, because it's a metal, right? Specifically, actually, I'm going to write here, this is an alkaline earth metal, right? Alkaline earth metal. So this here is my answer, 24.035, simply by just looking, simply by just looking at our periodic. The molar mass of magnesium is this answer here. So let me take a look at what they wrote here. Molar mass is given. Again, they did the exact same logic. I think it's the exact same person actually answered this problem. 24.035. Oh, sorry, 305. 305 here. So I actually wrote this wrong. This is 305. My bad. So I've mixed up my two numbers here. This is 24.305. Here's my answer, and this logic is correct. So this here, I'm going to say great solution and analysis, or I can say actually this is a perfect solution. Sweet. So so again, this here is number 8. So let me just see if I have any other questions. I might have another question here. Yes. Okay. This will be my last question of the day. This here is question 9. Question 9 states how many valence electrons are in the atom of chlorine. So this here states how many valence electrons in an atom of chlorine. Okay, so this was very, very similar to our problem, our first problem. It was the valence electrons of nitrogen, right? But instead, we're doing chlorine here. So chlorine, as we know, it's a non-metal, exists on the right-hand side. And if you want to the quick and easy way, you can simply just look at the group, right? It's group 17, which means I have 7 valence electrons here. I have here, this is 7 valence electrons. Remember, because my group number, the last digit of my group number, determines my the valence electrons, right? If I want to verify this answer, I could also draw a Bohr-Rutherford diagram like we did in grade 9. So I can have Cl here. I can use finally my circle tool. Again, I have my first shell here. Sorry, this will be my first shell. I have a second shell, and then I also have a third shell. Right? I have a third shell because this is in the period 3, right? So again, if I have 7 valence electrons, if chlorine has a atomic number of 17, which means I have 17 electrons, right? So this means I have 17 electrons. So again, I have 2 in the first shell, like always, 2 in the first shell. I'm gonna have 8, 1, 2, 3, 4, 5, 6, 7, 8, and then so if I have 2 in the first shell, 2 in the first shell, and then I have another 8 in the second shell, I'm left with 7 electrons in my last shell, which means I have 7 valence electrons in my last shell. And I'll draw that out for you. And that will be our last question for the day. So this here is I have 7 electrons. 1, 2, 3, 4, 5, 6, and 7. And this here is our final answer for number 9. 7 valence electrons for our chlorine atom here. 7 valence electrons. I'm going to shift back and see there are 7 valence electrons, chlorines in the valence shell. That's good. They determine what a valence electron is because it's just simply the outer last shell. They also use the electron configuration, but again, as a grade 11 student, we don't really know what this is yet, so don't worry about this. But this can also prove that the valence electrons are indeed 7 here. And they actually drew a Bohr-Rutherford diagram here. So it says 7 valence electrons. This here is perfect solution and analysis. So that takes us to 1 p.m. So again, thank you so much for watching. This was a review of kind of questions from grade 9, grade 10, and grade 11 science and chemistry. Kind of the first part of general chemistry if you're tuning in from the US. Again, thank you so much for watching. We answered 9 questions today in terms of these problems. What I'm going to do is I'm going to come back in about an hour or so, in about 2 p.m. Eastern time, and we're going to work on harder problems, specifically in the second half of general chemistry, and also and if you're in the Ontario curriculum, this would be SH for you. I'm going to answer questions pertaining to that course. So again, thank you so much for watching, and have a great day. Stay healthy, stay safe, and have a nice day.